If you are following our YouTube channel, you know that we already have a playlist about ideal gases. And we already discussed about the basics of ideal gases with this video right here, our overview for ideal gas laws. And then we discussed one by one kung ano ba tong mga ideal gas laws na tinatawag natin. Aside from that, we also discussed about the ideal gas equations. Now, if you already have those videos, then what's the point of having this separate video? Well, we're going to solve more problems in ideal gases. And aside from that, we are going to highlight the things that you need to remember when you are dealing with ideal gas in general chemistry. Okay, we learned from our previous videos the ideal gas laws. We have the Boyle's law, Charle's law, Lussac'S law, and the combined gas law. Okay, but actually there are just two important equations that you need to remember when solving ideal gases. First, we have our combined gas law, in which we have P1 B1 over T1 is equal to P2 V2 over T2, okay? In which our subscript 1 in here indicates our initial condition, and our subscript 2 here indicates our final condition. So this is an important equation na dapat matandaan ninyo when you are dealing with ideal gas in general chemistry. And then another important equation is our ideal gas equation, which is PV is equal to nRT, which we know that P is equal to pressure, V is volume, N is the number of moles, R is our universal gas constant, and T is our temperature. Now, we also learned that when we are dealing with ideal gas and we are using these gas laws and ideal gas equation, dapat yung mga variables natin dito are in absolute scale. Like for example, our temperature should be in absolute scale. That's why if we are having a temperature in degrees Celsius, you have to convert that to Kelvin. Similarly, if you have temperature in degree Fahrenheit, then you have to convert that into Rankine. Same goes to our pressure. It should be also on absolute scale. So, if it is not clear to you kung ano ba yung tinatawag nating absolute scale in pressure, we have a separate video discussing about pressure para maintindihan mo kung ano yung pinagkaiba ng gauge pressure, atmospheric pressure, and absolute pressure. And another important here is itong tinatawag nating universal gas constant. And of course, during exam, it is very rare na given itong universal gas constant. So therefore, you have to really memorize yung mga possible values na gagamitin mo in solving ideal gas problems. Well, most likely, yung madalas nating nagagamit is itong 8.314 joules per mole per Kelvin. And also this 0.08205 liter atmosphere per mole per Kelvin. Of course, itong iba is nagagamit din natin depending on the question that was given to us. So therefore, it is better na memorize natin itong mga universal gas constant natin when we are taking an exam involving gas laws. Okay, so sabi natin earlier, itong dalawang equation natin dito ang importante when we are solving ideal gas problems in general chemistry. And I will show you how you could use this in solving problems, and then we will do that sa succeeding problems natin. Now, we will be solving 5 problems on this video involving ideal gases. So, let's say we have Boyle's law. And we learned that Boyle's law is the ideal gas law that we will be using when our ideal gas is operating at constant temperature. So, as you can see, Boyle's law is operating at constant temperature. So, what do we mean by that? By using our combined gas law here, we have P1 V1 over T1 is equal to P2 V2 over T2. And we said that our ideal gas is in constant temperature process. So therefore, our T1 is equal to T2. In that case, our temperature will be cancelled out. And then that leaves us P1 B1 is equal to P2 V2. Okay, because sometimes you will be confused or you will forget kung ano ba yung Boyle's law. As long as you remember itong ating combined gas law, you can easily retrieve itong mga ideal gas laws natin. So let's say we have Charle's law, in which our ideal gas is operating at constant pressure. So our combined gas law states that P1 V1 over T1 is equal to P2 V2 over T2. Okay, and in this case, our pressure is constant, so therefore P1 is also equal to P2. So therefore, if they are equal, our pressure will be cancelled out. So this will be cancelled out, and this leaves us V1 over T1 is equal to V2 over T2. Okay, and this is Charle's law. Now, how about for Lussac'S law, in which our ideal gas is operating in constant volume? So our combined gas law states that P1 V1 over T1 is equal to P2 V2 over T2. And in this case, our volume is constant, therefore V1 is equal to V2. And in that case, our volume will be cancelled out because they are constants. And this leaves us P1 over T1 is equal to P2 over T2. And this is what we call the Lussac'S law. Okay? So, that's how you could retrieve itong ating ideal gas laws by using itong combined gas law. So, it will be easier now to remember ito na lang combined gas law when you are taking an exam about ideal gases. Okay? So, let us try to apply that by solving these problems. Now, we have 5 problems to solve on this video. So, problem number 1. When the volume of an ideal gas is doubled, while the temperature is halved, find the final pressure. Okay, so it will be easier to solve this problem if we could visualize what is happening, no? So, let us illustrate our condition. So, let's say we have here our condition 1. And then it goes to condition number 2. Okay? So this is our first or initial stage, and this is our final stage. And of course, in our initial condition, we have our initial pressure. Then we have our initial volume, and we have our initial temperature. And then, dito sa ating second or final condition, pinahanap sa atin is yung final pressure. So, we do not know what is pressure 2. And then, we are told that our volume is doubled. So, in our final condition, our volume 2 is actually 2 times of V1 because our volume is doubled, right? So, this means our V2 is equal to 2 V1. And then, we are told that our temperature is halved. So, therefore, our T2 is equal to half of our T1. So, we have T1 over 2. Okay? So, this is our final condition. So, let us now write our relationship, no, for these variables. So, we will be using our combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2. Okay? We are told that V2 is equal to 2 times B1 and our T2 is equal to T1 over 2. So, let us substitute that. So, we have P1 V1 over T1 is equal to P2 times our B2, which is 2 V1 over our T2, which is T1 over 2. Then, of course, we can simplify this. Now, we have P1 V1 over T1 is equal to P2, and then we have a denominator of 2 in our denominator. Now, we have T1 over 2 here. So, therefore, I can put this 2 in our numerator. No? So, therefore, this will be 2 times 2, which will be 4. So, 4 V1 over T1. Okay? So, ang requirement natin ngayon is to find itong ating P2. Okay? So, let us isolate P2. So, P2 is equal to P1 B1 over T1. Okay? Ito yon yung nasa left side ng ating equation. Then, we will transpose itong 4B1 and T1. Ano? So, T1 will be in the numerator. So we have T1 here. And our denominator, we will have 4V1. 4V1. Okay? So, as you can see, meron tayong mga variables that will be cancelled out. V1 will be cancelled out and T1 will be cancelled out. So therefore, our final pressure will be equal to a quarter of our P1. Okay? So this is our final answer here in our question number 1. Okay? So now let's go to problem number 2. Now in problem number 2, what pressure is required to compress 20 liters of gas at 0.5 atmosphere pressure to 1 liter at constant temperature? Okay, so we have a constant temperature process in here. And then we have our initial volume. Our V1 is equal to 20 liters. And then our initial pressure is equal to 0.5 atmosphere. And then our volume 2 is equal to 1.0 liter. It was compressed from 20 liter to 1.0 liter. Okay, then we are asked what is the pressure, no? The second pressure or final pressure natin. Okay, we have our combined gas law. P1 V1 over T1 is equal to P2 V2 over T2. Okay, we are operating at constant temperature process. So our T1 is equal to T2. So this will be cancelled out. Okay, so we have P1 V1 is equal to P2 V2. Okay, so ang required sa atin is P2. So we have to isolate that. So P2 is equal to P1 V1 over V2. Okay, so let us substitute itong mga values natin dito. So P2 is equal to our P1, which is 0.5 atmosphere, times our V1, which is 20 liters, over our V2, which is 1 liter. Okay, so looking at our units, you can see that liters will be cancelled out. So we can now calculate for the value of P2. So P2 is just basically 0.5 times 20, which means it is 50% of 20. So we have 10 and our unit is in atmosphere. Okay, so this is our final answer here in problem number 2. Okay, so now let's go to problem number 3. An ideal gas inside a closed system is initially at atmospheric pressure at temperature of 303 Kelvin. The pressure is increased by 1 bar. Determine the final temperature of the gas. Okay, an important thing to understand when you are dealing with ideal gas is understanding itong mga terms na ginagamit natin. For example, in here we have an ideal gas inside a closed system. So what do we mean if we have a closed system? It means that there is no mass or energy going in or out of our system. So for example, this is our system. So in this case, our material will not be able to escape from our system. So it will remain inside our system. So for example, here we have an ideal gas inside the closed system. So the particular gas will stay inside our system. Similarly, there will be no material coming from outside that can enter our system. So that is what we mean by a closed system. So if we have a closed system, that means our volume will remain constant. Okay, so let's say here our volume is constant. So let us try to analyze ano ba yung ating sitwasyon ngayon. Ano? So an ideal gas in a closed system is initially at atmospheric pressure. So our P1 is at atmospheric pressure. So it is having 1 atmosphere pressure. Okay, and a temperature of 303 Kelvin. So our T1 is equal to 303 Kelvin. The pressure is increased by 1 bar. Okay, so for P2, it is said that our pressure is increased by 1 bar. So when we say by 1 bar, it means we added 1 bar here. Hindi sinabing the pressure is increased to 1 bar. Okay, so it is said that 1 bar is added to our pressure. So that means our P2 is equal to 1 atmosphere plus 1 bar. Okay? So that's what we mean by that. Now we are asked to determine what is the final temperature. So itong hinahanap natin, our final temperature. Okay? So our combined gas law says that T1 V1 over T1 is equal to P2 V2 over T2. So we are operating under constant volume process. So our volume would be cancelled out. Therefore, we will have T1 over T1 is equal to P2 over T2. Okay? So, ang hinahanap natin is itong T2. So, let us isolate T2. Okay? So, we have T2 is equal to P2 times T1 over P1. Okay? So, now let us substitute itong mga values natin. Our P2 is equal to 1 atmosphere plus 1 bar. Okay? Now, let us be clear sa mga gagamitin nating mga units, no? Kasi kailangan consistent yung mga units natin. Okay, no? I'm going to convert lahat ng ating pressure into kilopascal, no? Para maging consistent tayo. So, ano ba yung mga conversion natin? So, ang conversion natin, 1 atmosphere is equal to 101.325 kilopascal. Okay, then 1 bar is also equal to 100 kilopascal. Okay, so yan yung mga conversion na gagamitin natin in solving this problem. Okay, so let us now substitute itong mga values natin dito, no? So we have our P2, no? Starting with P2, we have 1 atmosphere plus 1 bar. Now, I will convert this into kilopascal. So, 1 atmosphere is equal to 101.325 kilopascal. So, 101.325 kilopascal. Okay, so I'm sorry. We have kilopascal here plus 1 bar. So 1 bar is equal to 100 kilopascal times our temperature 1. Our temperature 1 is 303 Kelvin over our P1. Our P1 is equal to 1 atmosphere, which is equal to 101.325 kilopascal. Okay? So now, what will be our unit here? This is going to be in kilopascal, no? And our denominator is in kilopascal. So therefore, our unit for kilopascal will be cancelled out. So may iwan sa atin is unit na Kelvin. Okay? So what will be our temperature 2? Let us use our calculator. Okay, so we have 101.325 plus 100, then times 303. Now we're going to divide that to 101.325. Okay, as you can see, we have 602.04. Okay, so 602.04 Kelvin. Okay, so this is our final answer in here. Alright, so now let's go to problem number 4. Okay, so in here, sa problem number 4, we have the temperature of 3 liters of a gas is changed from 27 degrees Celsius to negative 10 degrees Celsius at constant pressure. What is the new volume in milliliters? So, kailangan na-express natin yung answer natin in milliliters. So, our condition here is constant pressure. So, our pressure is constant, no? So, let me write that in white. So, our pressure is constant. Okay? So, let us write our condition. We have our initial temperature here, which is 27 degrees Celsius. And then, our volume here is equal to 3 liters. And then, it was cooled down to negative 10 degrees Celsius. So, ang hinahanap sa atin ngayon, what is the final volume? And we have to express that in milliliter, no? So, let us use again our combined gas law. We have P1 V1 over T1 is equal to P2V2 over T2. And we are operating at constant pressure process, so our pressure will be cancelled out, no? Therefore, ang may iwan sa atin is V1 over T1 is equal to V2 over T2. Okay, so, ang hinahanap natin is itong V2, okay, our final volume. So, let us isolate that. So, V2 is equal to V1 times T2 over T1, okay? So, substitute na natin yung mga values natin. Our V1 is equal to 3 liters times our T2. Our T2 is negative 10 degrees Celsius, but we need to convert that to Kelvin, no? So, we need to add 273.15. So, this will be in Kelvin over our T1. Our T1 is 27, so degrees Celsius. But we need to convert that to Kelvin, so plus 273.15, and this will be in Kelvin. So as you can see, our unit Kelvin will be cancelled out, so our answer will be in liters, no? So therefore, our V2 can be calculated. Now, let's use again our calculator. So we have 3 times negative 10 plus 273.15, then divided by 27 plus 273.15. Okay, so we have here 2.63 liters, pero ang kailangan nating makuha is in milliliters, so we have to convert that into milliliters. So we have 1 liter is 1,000 milliliters. So our unit liter will be cancelled out. So our answer will be in unit milliliters. So our V2 is equal to 2,630 milliliters. Okay, so this is our final answer in problem number 4. Okay, so now let's go to problem number 5. An automobile tire with a volume of 0.8 cubic meter is inflated to a gauge pressure of 250 kilopascal. Find the mass of air in the tire if the temperature is 25 degrees Celsius. Okay? So, in here, hindi natin gagamitin yung combined gas law dahil wala namang binigay ditong initial at final condition natin. Ano? So, in here, given na ang ating volume, given ang pressure, and given ang temperature. So, ang pinahanap sa atin is yung mass ng ating air. So, that means, ang gagamitin natin dito is yung ating ideal gas equation, which is PV is equal to nRT. Okay? So, kailangan natin is mass, but of course, with this equation, ang makukuha natin is yung number of moles, no? Pero, isulat muna natin yung mga given natin. So, we have our volume, which is equal to 0.8 cubic meters. And then, we have our pressure, which is equal to 250 kilopascal. Pero, we have to take note that this is a gauge pressure. Okay, this is a gauge pressure. So, sabi nga natin kanina, so pasimula ng ating lecture, is that we have to convert this into an absolute scale. So, that means we need to add an atmospheric pressure, which is equal to 101.325 kilopascal. Okay, so therefore, our pressure is equal to 351. Okay, so 351.325 kilopascal. Okay, so that is our pressure. And then, given din yung ating temperature. So, our temperature is equal to 25 degrees Celsius. But we need to convert that to Kelvin. So, we will be adding 273.15. So, therefore, we have 298.15 Kelvin. No? So, yan ang ating temperature. And ang hinahanap natin is yung mass ng air. Okay? So, let us now solve for that. So, we will be using PV is equal to nRT. So, hanapin natin yung number of moles ng ating air. So, this is equal to PV over RT. Okay? So, substitute na natin yung mga values natin. Our pressure is equal to 351.325. So, 351.325 kilopascal multiplied to our volume. Our volume is 0.8 cubic meters. So, we have 0.8 cubic meters. And then, we have to divide it to our universal gas constant. So, in here, kung makikita ninyo, naka-kilopascal tayo. And then, we have in Kelvin, no, yung temperature natin. So, we are going to use itong ating universal gas constant here. 8.314 joules per mole Kelvin. No? Yan ang gagamitin natin dito sa ating problem. So, we have 8.314 joules per mole Kelvin. Okay? Kaya lang, kung makikita ninyo, this is in kilopascal. So, therefore, itong ating joules and moles should be also expressed in kilojoules over kilomole. But given that, we also have to multiply this by 1,000 over 1,000. So therefore, this is also equal to 8.314 kilojoules per kilogram mole Kelvin. No? So kinonvert lang natin sa kilo itong joules and kilo itong moles natin. So, it will be 1,000 divided by 1,000. So, it will be cancelled out, yung numerical values natin. So, therefore, it will just be equal to the same, 8.314, no? So, now we're going to multiply it to our temperature, which is 298.15. So, 298.15 Kelvin. So, i-check natin yung ating units. Kelvin will be cancelled out. But so far, yan lang ang nakikita nating unit, no? Kasi we still need to convert itong ating mga units para maging consistent. Okay? So, let us check first itong ating kilopascal. Let us convert this into kilonewton per square meter, no? So, we know that 1 kilopascal is equal to 1 kilonewton per square meters. Okay? So, tingnan natin yung unit natin dito. Kilopascal will be cancelled out. Okay, so dito naman sa denominator because here naka-kilojoules tayo. But we know that 1 kilojoule is equal to 1 kilonewton meters. Okay, so kung titignan natin, our kilojoule will be cancelled out. Our kilonewton will be cancelled out. And we have a square meter here and a meter here. So, therefore, magkakaroon tayo ng denominator in cubic meters. And then, we have a cubic meter in the numerator. So, this will be cancelled out as well. So, ano yung naiwan sa atin? Our unit will be in kilogram mole. And since denominator natin siya dito, that means it will be transferred sa ating numerator, no? So, therefore, our N will be equal to, let us now use our calculator again. So, let's start here. We have 351.325 times 0.8. Okay, then divided by here 8.314. Then divided by 298.15. Okay, so we have 0.1134. So, 0.1134 kilogram mole of air. Okay, so we need to get the mass of air. Yun ang kailangan nating makuha, di ba? Find the mass of air. So, therefore, we have to multiply that to its molecular weight. So, we have M of air, which is equal to our number of moles here, which is 0.1134 kilogram mole of air, times the molecular weight of air. So, we have 29 kilogram of air over 1 kilogram mole of air. Okay, so, our kilogram mole will be cancelled out. So, ang may iwan sa atin is yung kilogram of air. So, therefore, our mass of air will be equal to, so, ito yung initial na sagot natin kanina, yung number of moles, 0.1134. So, let us multiply that by 29. So this will be 3.288, no? So we have 3.288 kilogram of air. And this is our final answer sa question na to. Okay? So I hope that this video helps you in understanding further itong ideal gases natin, no? So ngayon, nag-solve tayo ng more problems in ideal gas laws and ideal gas equation, pero ang ginamit na natin is ito lang combined gas law. So we have teach you this method in case na makalimutan ninyo, because you might be remembering ano ba yung Boyle's law, ano ba yung Lussac'S, ano ba yung Charle's law. So in case you forgot kung ano ba talaga yan, you can really just use itong combined gas law, no? Okay, so that's all for now. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.